Okay, so far we have spent a lot of time on making a series of videos concerning just some of the basic properties of ordinary generating functions, and then we use generating functions to solve a whole variety of combination problems, in combination with repeats too, and some of the more complicated problems that you might encounter. And you notice that there's like a constant theme throughout all these problems, and that is you're usually left with some algebraic expression and you have to find the coefficient of x raised to a certain power. And we have just a couple of more problems here that gives us practice in doing that, because sometimes you could end up with expressions that are pretty complicated and you might have to do some computations to find the coefficient of x raised to whatever power you're interested in. For example, let's just suppose we had 1 plus x, say to the 5th, plus x to the 7th, and that's raised to the 20th power. And out of this expression, when this is multiplied together 20 times, suppose we have to find the coefficient, say, of x to the 17th. So find coefficient of x to the 17th power. Now, we look at this, of course, what we have is 1 plus x to the 5th plus x to the 7th times 1 plus x to the 5th plus x to the 7th times 1 plus x to the 5th plus x to the 7th. And we have a whole series of these so that they're being multiplied together 20 times. So here we have 20 multicands. And remember, of course, that when we're doing our multiplication, what we're doing is that we're essentially selecting out of each one of these multicands one of these terms that we're going to work with. We might select maybe an x to the 7th from this one, and a 1 from this one, and an x to the 5th from this one, and so forth. But each time, for each multicand, we could only select one term at a time. Now, if we want the coefficient of x to the 17th, how do we get that? Because it looks like there's only one way it can be achieved, and that would be to have x to the 5th times x to the 5th times x to the 7th. That will give us x to the 17th, and that looks like the only way that could be accomplished. So what would be the coefficient of that? Well, that's tantamount then to asking us when we're multiplying this together, how many ways can we select? X to the 5th from the 20 different multicands. And clearly order does not matter. The order in which we select them is totally irrelevant. So the answer to that question is just very simply, it's the binomial coefficient of 20. Amongst 20, we're selecting 2 of them. Among all these 20 here, we're going to select 2 of them where we have x to the 5th. So that gives us 2x to the fifths. That's the number of ways in which that can be done. Now, we said we had to have x to the fifth times x to the fifth times x to the seventh. So, out of these 20, 2 of them have been used already because you picked an x to the fifth from them. So now our question is, how many ways can we select one x to the seventh from the remaining 18 multiplexes? From the remaining, try to move this up a little bit further, remaining 18 multiplexes. And of course, that answer is just simply C, 18 over 1. So here, to get x to the 17th, when we're multiplying 20 of these together, we need to select 2 x's to the fifth and 1 x to the seventh, and we're asking ourselves, how many ways can we do that? Well, from amongst 20 of these, we get to choose 2 of them that have x to the fifth, and this is the number of ways that you can do that. Now there are 18 left over, and amongst those 18 that remain, we have to select an x to the seventh from one of them. How many ways can we do that? That's this. So now, the number of ways that we can do this together, well, to get these two, that is task 1. Then we have to select this one afterwards. That's task 2. And then to do them all together by the counting principle, the number of ways we can do that is the number of ways task 1 can be performed, that's this, times the number of ways that task 2 can be performed, that's this. So our answer then is going to be this binomial coefficient times this binomial coefficient. And this one is equal to 20 factorial. Here we're working now with this binomial coefficient, 20 factorial over 2 factorial times 18 factorial. That's this, and now we have to multiply it by this, and this one is equal to 18 factorial divided by 1 factorial times 17 factorial. So that's this times this is this times this. So here, of course, these are going to cancel. And we now have 20 factorial divided by 2 times 17 factorial. So let's just make some room and figure out what that is. We have 20 factorial divided by these cancels. So we have 2 factorial times 17 factorial. 2 factorial is just 2. So we have 20 factorial divided by 2 times 17 factorial. So let's see. This is 20 times 19 times 18 times 17 factorial divided by 17 factorial times 2. Those cancel. That will go into there 10. So we have 10 times 19 times 18, or 190 times 18, and I think put it on the calculator, 3,420. So from this expression here, one plus x to the 5th plus x to the 7th raised to the 20th, the coefficient of x to the 17th will be 3,420. So, and again, what we were considering is we're multiplying 20 of these together, and we realize when to get x to the 17th, we have to have x to the 5th times x to the 5th times x to the 7th, like this, in order to generate x to the 17th, and that's the only way we can get x to the 17th. So then we asked ourselves, well, how many ways can we do this, and how many ways can we do this, multiply them together, and then that's the total number of ways that we can do this selection here, and that number comes out to be equal to 3,420, and so that's our coefficient here for x to the 17th. So we've tried to provide a variety of problems that employ different methods for finding the coefficient that we're interested in, because there's no one technique that works in all different situations. So we're trying to provide a variety of situations and demonstrate in each one then how we can find the coefficient of x raised to whatever power that we're interested in. Okay, and if you just found us on YouTube, if you can go to the website at digital-university.org, all of the videos that we have concerning permutations and combinations and what we've done so far with ordinary generating functions and how we've used them to solve different types of combination problems, they're all listed in order for you there at the website. What we try to provide is have a series of problems that get progressively more difficult as we go along. Okay, that's it for this video. Come back and join us in the next video, and we'll try and provide another example of finding the coefficient in a particular generating function scenario, and kind of the thinking that goes in to helping us solve that. So come back, join us for the next video, and we'll try and solve some more problems.